Hello. Today we will be looking at AI, which is short for artificial intelligence and machine learning. In today's video, we will be looking at firstly, what is artificial intelligence and machine learning? We will then move on to what the difference between those two topics are. Then we will look at the benefit of AI towards organizations. After we look at the benefit, we will then look at the challenges of AI. And then we will look at examples of machine learning, and we'll then move on from examples of machine learning to what are predictive models. Then we will end this with the different types of predictive models. What is artificial intelligence and machine learning? Artificial intelligence, AI for short, is the broad discipline of computer science dedicated to building systems capable of performing tasks that traditionally require human intelligence. It encompasses a wide range of capabilities, from logical reasoning to problem solving to visual perception and natural language processing. Ultimately, AI aims to create autonomous machines that can sense their environment and make informed decisions to achieve specific goals, effectively acting as a digital mimic of human cognitive functions, as seen in this GIF here, which, if for those of you who do not know, is from a movie known as iRobot, which is actually about AI and the some of the dangers of AI and what happens if AI gets too human-like without any checks put in place. Now onto machine learning. Machine learning serves as a specialized subset of AI and acts as the engine that allows these systems to improve without being explicitly programmed for every possible scenario. It relies on complex algorithms and vast data sets to identify patterns and make predictions, allowing the software to learn from experience. By shifting away from rigid rule based instructions, machine learning empowers computers to adapt to new information independently and to refine their accuracy over time. Next, we'll be looking at the benefit of AI to organizations. Because now that we've learned about AI and machine learning, next thing is what's the point of learning all of this if we do not know how it's going to benefit organizations and by extension ourselves. Now, the first benefit is operational excellence and efficiency. AI fundamentally redefines productivity by automating high volume repetitive tasks and deploying what's known as agentic AI, which are autonomous systems capable of managing complex workflows with minimal oversight. Beyond simple automation, AI optimizes resources in real time, from reducing energy costs in data centers to streamlining global supply chains through predictive logistics. By handling the quote unquote heavy lifting of data processing and administrative maintenance, AI allows a workforce to shift its focus towards high value, creative, and strategic initiatives that drive the business forward. The next benefit is data driven strategy and innovation. AI acts as a sophisticated decision making partner by converting vast oceans of raw data into actionable intelligence. By identifying the subtle patterns and forecasting market shifts, organizations can move from a reactive posture to a proactive one, personalizing customer experiences at scale and identifying new revenue streams before they become too obvious to competitors. It is this predictive capability that reduces risks and accelerates innovation, which ensures that every strategic move that a business makes is backed by evidence based insights rather than just purely intuition, which ultimately fosters long term resilience in a rapidly changing market. Now, these are not the only benefits that AI has to organizations. There are many, many more benefits, but these are the two that I've chosen to explain on in today's video. Now, the difference between machine learning and AI. The difference between them is this: AI is the overarching field of computer science that's aimed at creating systems capable of performing human tasks that typically require human intelligence, such as reasoning, problem solving, and understanding language. You can think of AI as the broad vision or the ultimate goal, building machines that can mimic the cognitive functions of the human mind to act autonomously in complex environments. Now, machine learning is a specific subset of AI that provides the how behind the what. It uses algorithms to analyze data, identify patterns, and adapt without constant human intervention. Instead of relying on manual, hard coded rules for every scenario, machine learning uses algorithms to analyze massive amounts of data, identify patterns, and make predictions. It is essentially the process of teaching a computer how to improve its own performance through experience, which allows it to learn and adapt without constant The fundamental difference between the two lies in their scope and application. AI is the broad category that encompasses any technique that enables a machine to be smart, whether through logic, rules, or learning. Machine learning is a specific engine that drives modern AI forward by using data driven statistical methods. In short, AI is the broad category, the destination, while machine learning is the data driven engine, the vehicle that's used to get there. Now, what are predictive models? In the context of AI, predictive models act as the system's forecasting engine. Unlike traditional statistics that often rely on simple linear trends, AI powered models use machine learning to detect deep, nonlinear correlations within massive, high dimensional datasets. By analyzing thousands of variables simultaneously, the AI learns to recognize subtle digital fingerprints that precede specific events, allowing it to predict everything from consumer buying habits to potential equipment failures with remarkable precision. The real power, however, of these models lies in their ability to learn and adapt autonomously. As you've noticed by now, one key trend of AI is that it has the ability to learn and adapt autonomously without human input. As new data flows into the system, the model continuously refines its internal logic, improving its accuracy over time without requiring a human to manually rewrite the rules. This transforms data from a stagnant record of the past to a dynamic roadmap of the future, which enables organizations to shift from a reactive wait and see posture to a proactive strategy that mitigates risks and seizes opportunities before they fully manifest. Finally, the different types of predictive models. Predictive AI is not a one size fits all tool. Different models are designed to answer specific types of questions. While some models predict a specific number, others sort data into categories or identify hidden groups. By matching the right model to the right business challenge, organizations can transform raw data into a strategic roadmap, shifting from reactive troubleshooting to proactive leadership. Now, onto the classifications of predictive models. The first classification is the classification models, which is also known as a yes no model. These models sort data into distinct categories. A classic example is fraud detection that is used in banking, where the AI analyzes a transaction in milliseconds to classify it as either legitimate or fraudulent based on past patterns. Regression models is the next type of predictive model. It's also known as the how much model. They are used to predict a continuous numerical value. For example, an e commerce company might use regression to perform demand forecasting, calculating exactly how much inventory of a specific product they will need next month based on seasonal trends and marketing spend. The final type of model I will mention in today's video is the time series model, which is also known as a trend model. These focus on data points collected over time to identify cycles and fluctuations. A common use case is predictive maintenance in manufacturing, where sensor data from machinery is monitored to predict the exact window when the part is likely to fail, which allows for repairs before breakdown occurs. The key takeaway is that these models work together to reduce uncertainty and to optimize organizational resources.